Hi everybody, my name is Matt Griffiths. I'm the channel manager for Checkpoint, the UK and Ireland SEs. And joining me today is Matt Manning, who's one of my SEs. So we're going to be talking to you today about best practices for securing a hybrid data center. Now, this is something that's coming more and more to the fore. I mean, Manning, in your experience, and you've worked with lots and lots of different partners in your time, what are you seeing out there in the hybrid world?
I mean, we're seeing a far bigger demand than we've ever seen before. It's a real mix as well. We've had customers who have been hit by the pandemic and have had to start placing technology in the cloud for the first time. And we've also had new organizations that are completely based in the cloud and have done nothing on premise and are using all the crazy new advanced features that you get with that. So it's a real mixed bag, but it is growing really quickly. And I think it's a really good time for people to start getting their head around this.
It is growing as well. And one of the things about the cloud that a lot of people forget, or certainly with the hybridization of the cloud, is that it makes sense. You know, if you're building a huge data center and you want to add a simple bit of functionality, the cloud's a place you can simply get that on a consumable basis. You don't need to buy huge amounts of tins. So it is one of those things that really, in a way, most people out there should be expected to kind of be hybridized at least, which is effectively what we're going to talk about today. Exactly is hybridization. So we tend to think of hybridization as you have a data center and then you use some of the systems that are in the cloud. In actual fact, it's a little bit more nuanced than that as we go through effectively what we're talking about here today. So in the good old days, which is probably about 20 years ago, we would have a head office. Okay, that head office would have a data center. Now, this could be a proper data center stored in a purpose-built building, say for some of the bigger companies, but it could also, and let's all be honest, be a cupboard under the stairs. And in that, we've all been there. And with that, you know, you might be looking at your Exchange servers. You could be looking at some file sharing systems. There's a whole raft of stuff that you could have, and that's effectively what most people have. Throw in a little bit of internet as well, and that was all you had to worry about. You weren't really hybridized, you were connected to the internet, and you would have your own servers somewhere located around your system. But then things started to change. The biggest real change that we saw first off was the emergence of systems like, services like Office 365. So Office 365 took the server away from under your stairs in the cupboard, and it suddenly put it up in the cloud. And this was actually the first time, most people don't really realize this, that we started to hybridize our data estates. Because now there was a very good chance that actually you're using SharePoint in the cloud, your email was in the cloud. There were actually quite a few services they were starting to run. So at this point, and this actually happened quite a long time ago, we started the process towards hybridization. Now, the thing with Office 365, of course, it was very popular and pretty much hot on the heels of services like that, although they had been running slightly before then, but really it was just a niche thing, was we started to get the AWS hyperclouds. Okay, so we got AWS, we had Azure, now we've got GCP. This was where the real hybridization started to happen, where people that had systems that were in data centers, which of course are really expensive to actually run on a day-to-day basis because you've got power, you've got the cost of the actual kit itself, could start utilizing what Amazon had, which was massively redundant data centers with a huge amount of links coming into them. So this is when we really started to see hybridization start. But that isn't really the entire story. Because what we also started to see was things like branch offices. So we had branch offices all over the world, again, all connected back into this system. And then we had remote users. We started sending people home from work, and that's accelerated in the last 12 months or so. So people were working from work and needing to get access to those systems. People had mobile devices, and they were needing to get access into all those systems as well. And of course, and there's one we often forget, IoT devices. So as technology started to spread, more and more devices were starting to put it into our networks. Now, one of the really big things about this is, how do you secure this? You've now gone from a situation where a simple gateway could have protected your actual data center, but now your data's everywhere. It's in Office 365, it's in AWS. You might be storing some stuff in the in your actual in your branch offices, for example. And of course, people need to access it from all over the place, from their mobiles, from their laptops, and all working from home. So really, hybridization has been around with us an awful lot longer. And to try and imagine hybridization as simply connecting your on-premise data center up to a private cloud or a big hypercloud, kind of ignores the fact that we've been doing this a long time and there's data in other places as well. Great example being Office 365 or G Suite if you're using that. Look at how much data is actually stored up in that, and that's nowhere near your data centers. So one of the things we do need to talk about is the remote users. Now, in the last year, as I think we all may have noticed, there has been a huge drive to move people back to home due to COVID. Most of us are quite happy. I'm coming to you live from beautiful sunny Bury St Edmunds from my conservatory, as you can plainly see. I'm not in the office, and there's a huge amount of people that are no longer working in the office. So not only do we have the problem of the hybrid data centers, but we now have the problem with users all over the world simply trying to connect into that. I mean, Manning, what's your thought on the remote users and the changes that it's caused with the systems that we're using?
I mean, personally, I think that remote users has been around for a long time. We've been selling technologies to allow users to connect into, their corporate infrastructure from cafes and from the home. And I've always thought that they're super insecure and super sort of worrying environments when not set up and secured properly. Even at home, there may be people in your house who are bringing assets into your environment that you haven't checked. They're not compliant to your corporate requirements, and they're potentially sitting on a LAN in your own house that you wouldn't necessarily ever allow in your environment. Exactly. For me, though, I've seen the biggest change is not that users are connecting into a central location. It's the fact that your infrastructure, both compute and data storage, are in multiple places. And it's that I think is the real change we've seen in the last few years, is that not just a single data center or comms room, but also your information stored in a public cloud environment, in a SaaS solution, and in many other places. And that's the real big change we're seeing. And customers are really asking for us of ways to access that information in a way that is in a zero trust, that only poking the only holes they need in the environment and only giving the tiny bit of access that they actually require to do their job, and not exposing their entire estate to the world, just so that you can, access a shared drive or look at some emails and so on. That's the real big change I've seen.
Exactly. I mean, it's when you think about it in a slightly different way, if you want to secure that hybrid data center, you actually need to secure your remote users just as much, because they're the ones that are often coming in. And like you say, all it takes is your children to be downloading dodgy stuff on the internet. And I don't mean that in a sort of in a bad way, but a good example is my son's a massive Fortnite fan, strangely. And the other day he ran across an advert for a clicker, which he probably downloaded onto his laptop. And then I spent the next sort of hour trying to clean his laptop up from the malware that came on it. And of course, that's just in my local network. There's nothing to stop it, technically, jumping across into a simple VPN, like you said. So actually, when you're looking to secure a hybrid data center, you've got to secure it, but you've also got to remember who's actually accessing it and how to secure them. That's remote users, and just as importantly is actual users themselves. And maybe not a member of the company, maybe they're actually accessing the services that you're doing. So, I mean, remote users is extremely important when it comes to securing your entire data estate, because that's probably where somebody's going to try and get in the easiest. One of the things I'd quickly like to walk through, Manning, if you'd be so kind, is just what are we trying to secure? Because when you look at it, if you're trying to secure a data center, and then you're adding in things like SaaS services, and you're adding in hypercloud services and private cloud services, we're talking about hundreds and hundreds of different technologies. How exactly do we secure them all?
I mean, that's obviously the biggest challenge, isn't it? I mean, when we look at what we have had for years, we've had different types of on-premise environments. Most people are familiar with is that comms room. Again, days like today, there was probably a fan pointing out the window to try and cool the place. And in there, you have the traditional stuff you're used to, which will be, laptops, users' PCs, servers. They've always been really quite simple to protect, because the only untrusted area in that environment is typically, either the door, which you can quite easily put door access codes in, but actually just the internet connection. It's quite simple to put a perimeter around that.
Yeah.
Branch offices are definitely a big challenge. Like we mentioned earlier, people can, really secure down that head office, but leave the door, quite literally sometimes wide open in the branch office. IoT, we see a lot more of that than we've ever before. In this diagram, we have it as part of a factory, but it does exist in all the other locations as well.
Sorry, shown to us really well with the Colonial Pipeline hack the other week. Shut down the entire American infrastructure, really just IoT devices. I'd love to know how they got through that, by the way.
Exactly. And I mean, they've only just recovered from that today, and they've lost a lot of money doing that.
Yeah.
I, in a previous role, would recruit graduates from university to work in the cyber services field. And I had students that were, building botnets for CCTV cameras. And this was something they were just doing as a university project. So again, each of these different environments have different technologies that are very specific and are very unique to their needs. And this requires a security solution that is contextually aware, whether or not it's laptop security or a SCADA robotic arm or medical scanning system. You have to have technology that can provide you, safe, secure, and contextually aware, policies for each of those different environments, because you can't get away with just leaving your CCTV system unsecured, because some student will find a way around it and using your system for you and stuff. So
Exactly.
it's massively important. Yeah,
it is. And it's also been, this has probably been the one we're all most comfortable with, which is gateways. Okay, if you like you say, if you want to secure a head office, a good gateway will secure a head office, because effectively it's like a fortress. If you actually go to a branch office and with proper security, say one of our small Spark devices, again, you can secure that, and you can secure the factory as well. So we're probably most comfortable with this, with securing things like this.
I think, the next place that we see a huge amount of breaches is these next three areas are probably the places we see most. At the home, we spoke about that earlier, about ways that you can get malware into your machines in ways that you wouldn't necessarily predict. Mobile phones is a huge area for data leakage. We trust and we think that mobile devices are safe and secure. We trust the App Store, we trust the marketplaces, but things slip past the net, and it is possible for data leakage tools, for malware to come into these devices through what we see as a trusted store or a location to get this software. So we have to have software on those devices that can scan to check the behavior of those machines as well.
In effect, you almost want to go back to the same logic that you had at the head office, and specifically in the branches, which is you're going to need security on those devices to make sure nothing gets into the VPNs, which can then get onto your network.
Yeah, absolutely. And then the one area that we are seeing probably the biggest demand of at the moment, which is Office 365, G Suite, and other SaaS-based security. Email is becoming the single biggest way that companies are getting compromised.
Yeah.
Only last week did I speak to a company who had targeted phishing attacks against their business, and they were so targeted that they were actually mentioning the names of the people in the finance department.
Wow.
They were a recruitment organization. They said, this company has done loads of work for us. Can you please pay this invoice? Jan in accounting, can you pay this bill for me? And here's the bank details. Oh, by the way, it's a slightly different account because they've changed who they're banking with.
Yeah.
And it was only because they had an internal process that had a payment threshold that they caught that. So you have to have technology that's not just looking for scanning of files for malware and ransomware and all those scary things, but also that human factor as well, that social engineering factor. You need technology that lives in that world, that is looking for those pressures, please click this now or else something bad will happen. And again, this is a really important area that you secure at the moment as well.
And it's one that you don't have a lot of control over either, is it? Because it's entirely Microsoft's. You can't phone Microsoft up and say, would you mind me putting a gateway into your Office 365 system? They'll look at you and go, well, absolutely not. Why? And it's one of those things that you have no control over these systems. So you have to trust that Microsoft are doing a good job. Now, granted, 99% of the time they're doing a great job, but you're right. Those phishing links that are coming through, the ID level attacks, which, like you say, they're either trying to get payment, or even better, simply send you an email with, click this link, this is your great new pay rise, only for you to start downloading some malware that floods your entire network. And we saw that only a couple of weeks ago with the Irish health sector, where malware got into their system, and started encrypting all of their back-end devices. And how to get in? Single device every single time. So,
Exactly.
yeah.
We have to remember that these companies are selling IT services. They're not selling security. And that is something that I feel you need a company that is sort of dedicated to that focus, because, you know, IT services are great and they set us up and they help the world work, but they don't actually always give us everything we need to protect ourselves. And that, I think, is probably, you know, tenfold really when you actually look at public cloud.
Absolutely.
Which is what we got here, I think, next.
And the other thing as well is for certainly for us as security engineers, it's quite this is where we start to get a bit strange, because now we're not looking at software and devices, we're not looking at gateways, we're looking about systems that are using APIs to do this, coming in at the back end, which again is strange for us as engineers. We kind of sit there and we think, well, how does this really work? It's all sort of, you know, as I used to call it, magic gnomes, working away in the background to make sure that you're safe, and you have almost no control over it.
It's like, where's the network path? Where do we put ourselves in the network path? We can't do it. So
yeah. And then of course we have good old cloud. Now this is usually where most of us traditionally think that hybrid security lives. We have something in the head office, we have some stuff in the cloud, maybe AWS, maybe Azure. For the more daring of us, maybe Ali. We have both the big hyperclouds and we have the more we have the hyperclouds, and we have also the private clouds as well. So now you're starting to shift your workloads from the head office up to these clouds. And the problem with these clouds, of course, is that they're a heck of a lot more complicated. So when we look at what's available in the clouds, and certainly where the industry is going, we start to see really quite a complicated picture of how to start securing things. So if you're looking at what I would call a lift and shift strategy, so let's imagine you're using Azure, you've decided to take your web servers from your on-premise database and pop them in the cloud. Generally, you can secure that fairly easily with a virtual gateway. The routing, especially on AWS, can be very, very difficult. But generally, it can be done. It's not the best way of doing it. And the reason it's not the best way of doing it is that we're now starting to move into a world of DevOps practices, where we're looking at very, very fast code. We're looking at DevOps teams that are deploying code as they're writing it. And they're also using sort of functions that don't come within the remit of what we would call a traditional sort of cloud or private cloud architecture. Great example, and I'm just going to drop down there to serverless workloads. If you're using serverless workloads, there is no underlying infrastructure that you can access anyway. I mean, it is there at some point, but you can't actually access it. So again, how do you secure a tiny piece of code running on one of AWS's or Azure servers? Becomes incredibly difficult. And actually one of the main ways that we're seeing hackers getting into systems now is through what we call functions. So you're having these people that are writing functions that just have a few lines of code in it, maybe a couple of hundred lines of code for a particularly big function. We don't actually know what's going on with it. And they're being deployed for maybe minutes at a time and then being withdrawn again. So how do you actually start securing that? You've then also got things like Kubernetes or Docker, okay? Again, you can't really get decent gateways that will actually secure Docker, certainly not on the east to west path. Sometimes you can get, systems, I think, off the top of my head, I think NSX do something where they're securing the north to south path. But that east to west path is always incredibly difficult. And these things are being written at a phenomenal rate and are usually, only in existence for a few minutes. So you've got all this lot to worry about as well. And the other thing, of course, is automation. So as you start to take advantage of what's available in the cloud, which is why you've turned up there, you're going to naturally move to automation. And you're going to be having DevOps teams and infrastructure teams are going to be deploying code, and they're going to be deploying code extremely quickly. You can't even write a policy. Gone are the days where you'd phone somebody up and say, could you put the port through on the gateway for us so we can speak to the internet? It's now literally deployed as, say, a Terraform template, built. It's in action within about sort of 15 minutes. It's running. 2 hours later, the whole lot might be torn down again and never, ever used. So we've got this horrible thing that kind of occurs when we move into the cloud, and especially the hyperclouds, where additional functionality, whilst absolutely brilliant, is incredibly difficult to actually lock down and actually sort of probably secure. And that, of course, is how hackers are getting in. They're looking for those simple little mistakes, maybe some credentials left in a function, maybe some credentials left in a Docker container. They might be looking for some bad privileges, so that once they get into that container, they can literally access the entire infrastructure on the back end of it. And again, how do you how do you actually control that, and especially how do you secure that? So one of the things we can do when we look at the hypercloud is just start to sort of think about how we flow through. So most of you watching this today are probably already going to be on this journey to a certain degree. Some of you may be beginning the journey, some of you may be well advanced, okay? So generally you'd start off, and Manning, you sort of tell me here what you would see in the industry and the way that you see people dealing with this.
Oh, wow. I mean, first of all, I wish I had a cookie cutter customer. I mean, no customer ever looks the same. We have customers who are, large, custom built data centers, not just a colo, but their own physically built premises. And they're starting to look at using cloud. I often meet customers who are completely cloud integrated and are using all of those more advanced, more modern functions, such as containers and serverless functions.
Yeah.
And it's a real mix, really. And I think it really depends on the blend of traffic and the blend of storage and compute requirement they have that really makes up what they need and where they're coming to us. It's really different, really different.
It really is, and I think for every single customer, it's different as well. I mean, this flowchart gives quite a good idea. You'll often start off with a single DC. You may have two DCs. At a certain point, you're going to start to think, well, actually, I don't like that sort of clunky traditional architecture. Let's move to something more of a building a private cloud, maybe, or hiring a private cloud. You start using Cisco ACI, maybe VMware NSX. Gives you a lot more flexibility. You start playing with it. You're thinking, this is nice. Then at some point, and a lot of people are going to skip that private cloud step, by the way, at this point, you're going to start looking at those public clouds. You're going to take advantage of the huge scale they have, the massive bandwidth, the ability to scale infinitely and collapse down again really, really quickly. And this is usually what happens. People kind of take this journey. They probably will have a single DC at the end of this when they're all done, but it may not be doing the same functions it was doing a few years ago. As soon as they start to move to the public cloud, they're now going to start asking themselves, how do I really secure this? Because I don't have the same level of control. Do you remember the old pictures, Manning, of it's usually an internet cable when embossed on the cables in case of hack cuts cable. That's gone. It's absolutely gone. That no longer exists. And then the worst thing is, I say the worst thing, but where you really do start to lose control is when you've started to use the cloud. Someone somewhere in your organization will usually start about automation. And when automation kicks in, this is the really big problem, because you're now looking at stuff that's being deployed. I mean, I was reading the other day, I was actually on an AWS lecture, and they're now up to code deployment over 100,000 times a day. So they're actually building things, they're changing code 100,000 times a day, which is, absolutely mind-blowing. How do you secure something that's being deployed that quickly? You can't phone James up, the IT security guy, and say, was there any chance you could do this? For a start, he probably couldn't do 100,000 changes in a day. So it has to be automated. And this is what we see all the time. You start off with that single DC, somebody moves to the cloud, somebody moves to a private cloud for more flexibility. Before long, they're also using the public cloud as well. That's where the real problems can occur if you're not securing properly. And then you start to automate. And at that point, control can be completely lost. So I actually spoke to loads and loads of engineers who literally will turn around to me and say, I have no control over my network. I just don't have it anymore. They're deploying stuff so quickly and it's all automated. I just don't know what to do. So just remember that, everybody. When you're looking at what's going on, it's a journey. It will accelerate, and you'll all be doing automated deployment fairly shortly. So it's important that we start to secure it now.
Yeah, absolutely. I think that visibility bit is key. Years ago, we used to have people, doing URL filtering reports for customers, and they would say, "Oh, my staff wouldn't ever possibly look at this in their lunch breaks." And you show them a report, and they're, so and so was looking at what. Actually, we're having similar conversations with our customers. Oh, well, my IT administrators, they're certainly not using Azure, and we're an AWS team. Connect things up and have, oh my goodness, they are using Azure. What are they? Oh my goodness, there's a £2,000 a month of spend in there, and it doesn't really matter. IT administrators think they've got a full handle on their environments, but sometimes actually things happen that go under the radar a little bit. So it's really important to kind of have a good idea in your mind as to what you're trying to achieve with security, particularly with such a big landscape. So hopefully we can go through some easy steps that people can take.
Yeah. So one of the things I want to quickly talk about now is best practices. Okay. The first thing you need to do is you need to understand that your data is sprawled. Now, one of the important things to remember about this is you may not be aware of that fact. And to use a good example, I was actually working with a bank a couple of years ago, and I asked the network security team, are you using the cloud? Came back, no, we would never use the cloud. We're a bank. And I was actually speaking to another partner of ours at the time that was basically saying, yeah, we're doing all this massive cloud work for this bank. They genuinely didn't know what was happening, and it had been happening for a year. It wasn't like, all of a sudden it happened in the last week or so. This stuff had been up in the year. So understand your data is sprawled, and you may not be aware of where all your data is. So in order to correct that, you need to discover all the points in which connect into your data estate. So what I mean by that is that you need to know exactly where all your data is, and you need to know every single connection point into it. And that may not be a direct connection. So for example, if you are using functions could be running at the back end, but somebody could hack into one of those functions. And if you don't connect with those functions, if you don't secure those functions, they're going to get in and get a breach. And just to show on here, that breach can happen anywhere, and they only need a single hole or a single device to get in. And some of the biggest sort of infrastructure attacks that we've seen have been stupid things like, a valve that's connected to the internet has got a vulnerability in it, and that's how they compromise the entire underlying infrastructure of that company. The other thing you need to understand when you're working with clouds, and especially when you're working with a hybrid data center, and especially with the big hyper clouds, is you need to secure each and every device with no exceptions. If you're using functions, they must be secured. If you're using containers, they must be secured. But also, if you've got people that are connecting into those clouds to do work, you need to make sure that the devices that they're using to do that with are also secure. There's no point having the most amazing secure data center alongside a really amazing secure, you've done your work, you've sorted it all out. It is an amazingly secure cloud system. And then the person that's logging on to do the changes has got more malware on his laptop than he cares to mention, and that's how it gets in. So you need to secure each and every device. If there's any device out there that doesn't have security software of some description, either on it or directly in front of it, you could be in trouble.
Even the ice cream machine that has a sensor on it that is doing temperature sensing to make sure the soft scoop doesn't go soggy. Even that, Matt.
Exactly, and that's one of the things. And when we speak to the IRT teams, one of the things that they see is the really good hackers. So we're talking like the nation state hackers when they want to get into something. That's how they're getting in, through ice cream machines or through an IP camera or something along those lines. They're not going to come straight in the door. They find the weakest point. You must secure everything. And the other thing, as Matt mentioned, is visibility is the key. If you don't know where your data is and you don't know what's happening to your data on a minute-by-minute basis, so we're talking things like XDR systems here, how do you really know whether you're secure? We can offer you as much security as you can eat, but if it's not actually secured properly, you need to have a good look into those logs. You need to be able to see there and sit there and say, oh my God, we've got a load of systems that just sprung up there. Why have they sprung up? Why don't they have any security on there? So understand visibility is the key. The other thing that's really important, and it often gets lost, is that the security that you do must be in context. So for example, traditionally you would put a big old gateway in front of maybe your entire data center, because this was pre-hybridization. You could turn all the modules on and pretty much it would be absolutely bomb-proof. You don't need to do that if you're simply looking at a function. Or to give you a better example, if you're not using a web server, why would you use WAF functionality? You don't need it. So different systems will require different rules. And you'll kind of see this when you start, I'm sure you'll be doing it at some point soon, when you start using functions and you start using containers, you don't need to have the same rule bases on those systems, because you may only need access control on them. You may need access control on IPS. You may need everything on them. But the system, the context of the security depends on the system you're putting it on. So in effect, you're not putting huge gateways everywhere. You're putting exactly the right amount of security you need to secure that device.
Exactly.
Okay? So those are largely the best practices that I certainly see as we move forward into expanding out into that huge data estate and the hybridization message. So just as a question, Manning, how do we as Checkpoint sort of help secure all those different technologies in all those different locations all over the world?
Yeah, I think for me, it comes back to that contextually aware part, is that Checkpoint, as a software company, we've been very adept at pivoting to different places where IT infrastructure springs up. Because we can take our software stack and we can place it anywhere, but we're very good at kind of tailoring it for that particular environment. So it doesn't matter if you go for the three traditional ones at the bottom of this. We can do large scale, hyperscale technologies on premise that can do multiple terabytes of throughput of threat prevention, small localized devices that can have small office features such as wireless and DHCP features. And then for those factories, we can do the gateway that has to withstand ridiculous temperatures and those sorts of harsh environments.
Yeah.
But also specifically when we get down to that contextual environment, our quantum protection technologies that understand those particular pieces of very specific hardware. There could be a medical scanning device where there's only 5 of them made in the world. And you need a technology that's written very much for that, and we can help in that environment. At home, we have laptop and mobile phone technologies that can know exactly what to look for in those environments. We have huge amounts of sensors that listen on those devices, not just for the known malware, but also for unknown malware. So we have the ability to emulate and sandbox different pieces of new, fresh malware that are hitting those environments. And that's port control coming in, that USB keys being plugged in, as well as files that you're scanning on the internet.
Yeah.
Matt, you touched very briefly on the email piece and API connectivity. And that's exactly what we do. We don't stick ourselves in the MX records, because things like OneDrive and things like that, you can't do that. We connect into the APIs of all these platforms, and we're able to take those files and scan them and analyze them. So it doesn't really matter where customers choose to consume that technology. We have a solution that we can place. And all of this is accessible via a single central online cloud-based management platform that you can look at to do this.
Yeah, because I think it's important to remember that we're offering almost like complete protection, as complete as we can do. We're looking after the head offices. We're making sure the branch offices are covered, like you say, even down to the individual machines themselves on an IoT platform. But then we're also making sure that you're not getting a breach to a laptop or a dodgy mobile phone. And we're also stopping that kind of the ID theft that we see in mail systems, and people stealing documents that you've got. Excuse me, on the likes of OneDrive or Dropbox or something. And it's that kind of completeness of vision, I think, that you really do need to look at on this.
Absolutely. And then when we think about the cloud side of things, and we'll probably rattle through this quite quickly, we can throw a perimeter around your cloud environments. We can stick an infrastructure as a service firewall in front of that. For us, that was very trivial. We just took our existing technology and just modified it and made it available for the cloud. Where we step on and we look at those more advanced, kind of more modern features, if we're looking at these types of technologies, containerization, serverless functions, and infrastructure as code, and not neglecting the posture management, so the configuration, misconfiguration that has been made in the cloud environments, we again have solutions that can fit each of those different environments, and they're all going to be looking at very different types of scanning. And very different types of checks from a security perspective. Posture is looking at configuration. AppSec is going to be looking at the dependencies inside your containers. workloads. It's going to be looking at what those serverless functions are doing, and so on and so forth.
Yeah. So the other thing I just want to bring up as well is the nice thing is the shift left down the bottom, which a lot of our customers don't realize that we do. What we're doing with shift left is we're actually doing the security scanning as it's being coded. So effectively, as soon as the developer finishes a bit of coding, hits commit, we're checking, are there vulnerabilities in this? Is it being deployed as per company security policy? Am I going to build some stuff? And if we get to a point where we see there's a vulnerability in there or it doesn't apply with the company security policy, we can abort the build, let the developer know, and then pass the code back to them to say, actually, you've got to try a little bit harder here, guys. And that's one of those great things about automation. We're actually kind of changing the way that we do security policies, in that the security policy is no longer that big rule list that you see on a gateway that we're all sort of very familiar with, but it's now more of a like a set of rules within the company. You know, you can't deploy this, you can't do that without this, and that's where shift left really comes in. That's one of the great ways of securing when you start moving into that automation phase. So just to wrap up quite quickly, one of the great things about Checkpoint is that we do have a full spectrum of security tools that we make available to our customers. Obviously, very, very well known for our traditional gateway devices, but we have a huge and extremely good system that secures in the cloud. Again, all driven by the single portal. We can secure the users and access into all of those systems so that we're cutting off that particular point of attack. We also have full SOC systems as well and threat intelligence to let you know when something is going wrong. It's part of our threat cloud, probably the world's biggest sort of threat intelligence system. It sits out there, it looks for things. It's then going to start looking into your network. If it starts seeing strange behavior, it's going to let you know. It's going to turn around and say, Manning's laptop appears to be strange. Could turn around and say, why am I seeing all these permissions being changed on a virtual function? And bringing that all to you into a central location, which just makes it easier to actually fully understand. That really is what we call our Infinity architecture, as you can see down the bottom there. Infinity SOC, the quantum, there's Infinity all over this. And the beautiful thing about Infinity, not only is it a wonderful method of securing absolutely everything that you have in your network, especially if you're running a hybridized network using both traditional methods, cloud-based methods, and you have people coming in and out so we can secure the remote users. It's a full spectrum security suite. The nice thing about it, of course, and many of you don't know this, but it seems like a good time to tell you, Infinity, or all our products together, are available as an ELA. So what that kind of helps with is one of the issues that I've certainly seen within the industry is that as people move into the cloud, they suddenly realize they have a problem. Maybe they can't secure their functions. And I'll just use the functions just as an example. They then have to go out, source, decide what technology they're going to use, speak to procurement. So procurement will then start speaking to the partners and trying to get a better price. And by the end of it all, you're sort of 2-3 months down the line. What Infinity allows you to do is simply consume whatever you need. So if you get to a situation where, as you as a security engineer have decided that, oh, my functions aren't secured, I need to secure my functions correctly, you can simply download the licenses and start using it as per your ELA agreement. So it's one of the great things about Checkpoint, I think, that we do offer that full spectrum of security, and we also offer it to you in a method that's very, very easy to consume and doesn't cause the sort of drag on security that procurement cycles often cause.
Yeah, one of my previous roles was in technical support, and one of the most common questions that came into the support desk wasn't about the technology or anything like that. It was, my support has expired. Can you still help us? Yeah. And that was because procurement drags, and it became so big that one of my colleagues had to learn a programming language, and he wrote a database to manage it. And when I left that role, I think we were somewhere around 2,500. We called at the time favors or exceptions, where we'd allowed customers. We continued to support our customers despite the fact that they were not paying for the services. And every single one of those was due to a delay in procurement. Yeah. And we have customers coming to us today who are saying, I just want everything in one date, one time, one price, and per user. And this has been built off of the the questions that our customers are asking, and our customers have said, please build this for us, and we've done exactly that.
Exactly. Yeah. No, that's very true. The procurement cycle actually causes a lot of problems because hackers don't need a huge amount of time.
No.
It's taking you 3 to 4 months to actually get the right bit of kit that you need. They can be in, out, taking your database, and at which point you're kind of thinking to yourself, great, that's that's like closing the door off the horse is bolted. So I hope you've enjoyed this session. We tried our best to sort of explain to you the modern state of hybridization. Like we've said before, you need to understand that hybridization is bigger than simply having a cloud data center, okay? Your data sprawled everywhere. You're looking at the Office, the Office 365, the SASE services. You're also looking at a big cloud system like AWS, probably your own data center along there as well. You need to understand the sprawl. You need full visibility on the sprawl to fully understand where everything is, and you need to secure absolutely every single component of it. In our view, the best way to do that would be through Checkpoint. But once you've done that, and if you wish to give us a call, please reach out, and we'll be happy to chat to you about any of the subjects discussed here. But you should actually have a fairly secure data center. It takes a bit of time. It's a little bit hard to work on, but it also means that you can actually go to bed quite happy knowing that you've secured your data center to its fullest extent. So with that, I'd like to thank Manning for joining me on this call. I'd like to thank you for giving us your time. I hope you've learned something. Please always feel free to reach out to us. We're always quite happy to take a chat. We'll be in the chat fairly shortly. If you wish to speak to us after this, that would be absolutely great. Thank you for your time.